Assalamualaikum and a very warm welcome. We are from Group 8 and we're going to present regarding space exploration from Chapter 10. Now we're going to introduce our team members, which are Daris, Imran and Danish. Now we're going into 10.1, which is development in astronomy. History of the solar system model are divided by three, which are Ptolemy, Copernicus and Kepler.
Okay, next, moving on to the history of the solar system model, we will talk about the three solar system models made by the three astronomers that were mentioned before this. And first, we're going to be starting with the geocentric model. So the meaning of the word geocentric can be divided into two parts, which are geo, meaning earth, and centric, meaning center. So in the geocentric model, Earth is at the center of the solar system and Earth is stationary, while all the other objects in the solar system such as the Sun and other planets revolves around Earth in circular orbits. Next, we're moving on to heliocentric model, where centric remains the same meaning, which is center, but helio means sun. So in this model, the Sun is at the center of the solar system instead of Earth, and Earth rotates on its axis and revolves around the Sun, still in a circular orbit. Lastly, we'll talk about the third solar system model made by Kepler, where he modified the heliocentric model with the Sun at one common focal point on elliptical orbits of the planets according to Kepler's law. Okay, next we're moving on to 10.2, the development of technology and its application in space exploration. So in this slide, we will talk about the developments in technology and also the accomplishments of humans in its respective year. For example, in the year 1961, the first human to orbit Earth, Yuri Gagarin, aborted the spacecraft USSR Vostok 1, and on the year 1969, the first human to set foot on the moon is Neil Armstrong aboard the spaceflight US Apollo 11. And a few examples of the technological developments in space exploration are in 1989, the first Neptune flyby was done by US Voyager 2. Meanwhile, in 2011, the construction of International Space Station, or also known as the ISS, was completed.
Moving on into 10.2, which is applications of technology in space exploration and their importance, which is the Space Telescope. The astronomical sextant is used to measure the altitude of the stars. Galileo's telescope became the most widely used astronomical instrument. Other than that, Hubble Space Telescope was placed in an orbit 500 km from the surface of Earth. The Spitzer Space Telescope detects very distant activities in space. And lastly, apart from optical telescope, radio telescope are also used to detect radio waves from space.
Next, we will be talking about the rockets, the satellites, and space probes used in space exploration. So, rockets are widely used in space exploration. When the fuel in a rocket burns, hot gases are released at high speed to the bottom of the rocket. So, the release of these gases produces a force which pushes the rockets upwards until it reaches space. Next, we will be talking about satellites. As you can see in the picture, the first satellite, which is Sputnik 1, was sent to outer space in 1957. The next, the space probe, which a space probe is a spacecraft that gathers information and sends it back to Earth.
Going on to our last slide, which is 10.2, applications of the technology in space exploration and their importance. Remote sensing. Remote sensing is a method of gathering and recording information from a distance. In Malaysia, remote sensing instruments are fitted to Tiungsat-1 to receive or detect visible, ultraviolet and infrared lights produced by objects on the surface or below the surface of the Earth. The information gathered by Tiungsat-1 is sent to two data receiving stations at the National Planetarium Station, Federal Territory of Kuala Lumpur, and the Mission Control System MCGAS, Bangi Selangor. Remote sensing technology is used in various fields in daily life as follows: agriculture, which is to detect suitable regions for agricultural development; disaster management, to identify pollution and forest fires; defense, to detect intrusions of enemy ships, aircraft and vehicles; and lastly, geology, to detect locations such as mineral sources